Chapter 13, Problem 19. In this particular case, we have a capital budgeting problem, and we have various cash flows. So once we've read the information, we find out that in this case, under the oil well scenario, for the first 4 years, there are no cash flows. For years 5 to 10, which would be 6 periods of time. Remember, there's 10 so far, and the first 4 there's none, so that means there's n would be 6. You find the present value of that amount of money. And remember, you have to discount it twice. So you have to find the present value for 6 years, and then bring it back another 4. And you wind up with the $261 million number at 12%. You do the same thing for the final 10 years, from year 10 to year 20, and you get 200 million a year, but it's further into the future. You bring it back with n being 10 to year 10, and then you treat it as a future value amount and bring that back to 0. And we've done this several times in the course in chapters 9 and 12 in particular. You find the present value of that, and it's $363 million, almost 364. The present value of the inflows totals to be about 625 million. You subtract the $500 million investment, and you wind up with a net present value of $125,131,487. So that would be above the 12%. Now, the aluminum smelter, in this particular case, as we found, only has a deferral period of 1 year. So there's no cash flows for the first year, but you start to get your money back much sooner, although the amounts of money are not nearly the same to the same level they were for the oil well. So in this case, there's 19 periods of 87 million. So PMT is 87 million, and the N would be 19. So you bring that back and calculate that number, and then once again, you bring it back 1 more year from year 1 to year 0. You wind up with 572 million. You subtract the 500 million initial amount, and you wind up with a net present value of 72 million. Now, by that self, the 72 million, because it's a positive number, you would accept. But if you have to look at the fact that they are mutually exclusive, that they're not, you have to pick one or the other. We'd like to do both. But if you have to pick one, you'll pick the one with the higher net present value. Now, in part B, it recognizes the fact that the oil well is a riskier endeavor than the aluminum smelter. Both of them have a level of risk, but especially in today's world, oil wells have even higher risk because of environmental factors and uncertainty of oil prices, although you still have uncertainty of aluminum prices. So in this particular case, rather than using a 12% discount rate, we factor in that the oil well is 4% more risky, like 4% higher discount rate. So rather than using 12%, we use 16. We go through the exact same process we did in part A, and only thing we change is the 12% to 16. All the other numbers stay the same. Obviously, our present value will go down because we're using a higher discount rate, and you wind up with a present value of $422 million. The net present value is negative $77,372,632. So in this particular case, by itself, you would not invest in the oil well. It does not give you a sufficient rate of return. You make money off of it. You have positive profits, but not to give you a 16% of rate of return or higher. You can see that because at 12% it's positive and at 16% it's negative, the internal rate of return is between the two. then their internal rate of return is where net present value is exactly equal to 0. So you go from a positive, which would be yes, to a negative, which would be no. And once again, in this case, you would reject it if it was just your sole option. But in this case, you would reject the oil sands or the oil mills or oil wells and purchase the smelter, because the smelter has a positive net present value, and in the higher discount rate, the oil wells do not have a positive number, and it's certainly less than the positive number of the smelter, aluminum smelter.